everyone, welcome back to the Advanced Machine Learning course part 1 by Life Changes Academy. So in this course we are going to learn about the deep learning fundamentals and also we are going to understand how the artificial neural networks work, okay? And then guys, you have probably heard a lot of buzzwords like artificial intelligence, machine learning and neural networks flying around, right? So but today's session we are going to identify all of these kinds of words and also we are going to look at how these systems are inspired by our own brain structure, as well as we are going to process the raw data, raw information, okay? And then how we will going to see how they actually learn to make the decisions, okay? Okay guys, so without any delay we will move to this session. So first of all we are going to learn about the deep learning, okay? So deep learning is nothing but it's like a branch of an machine learning, okay? So it will be going to uses the structure, that one is called artificial neural network, okay? That is mainly used to learn from massive amounts of data, okay? So guys, the biggest game changer here is that it requires no manual future engineering, okay? Now what does it means understand clearly, okay? So in traditional software, this traditional engineering, traditional software engineering period and all, we have to write the rules for the computer, okay? And then in traditional machine learning and all, we still have to do a lot of preparation to make the system to learn the patterns, okay? But what I am saying means telling a computer that this one is called a cat contains the 2 ears and then 1 nose. Likewise we will be identifying the parts and then we will be giving to the computer to learn the pattern, okay? But in with the deep learning only, it will be automatically changes everything. That means it will be blast. Why? Because means we will be just feed the network raw data. Network raw data is nothing but we will be just sending the pixels of an images, okay, or else pixels of an audio waves, and the network, it will be automatically detect the pattern and learn the future by itself, okay? See how powerful the deep learning is, right? So the deep learning will automatically learns the data from the patterns, okay? We will not going to tell that this one is a cat, this one is a dog, this one is a flower. Likewise we will not going to compare everything and we will be not going to say that this one is a cat dog. It will be automatically identifying the pattern and it will be learned by itself, okay? So see the power of the deep learning, okay? So guys, in your day-to-day life we will be go through with the deep learning only, okay? How means through image recognition. Image recognition is nothing but we will be recognizing our images, right? How means automatically we will tag our friends in photos, right? And then speech recognition is nothing but converting your voice into text when you talk with the Siri or else Alexa. That AI will be automatically converts your voice into text and it will be giving the responses, right? And then language translation, it is nothing but it will be translating the complex languages. That means complex sentences across long languages, okay? And then autonomous vehicle is nothing but it's like a self-driving cars or a self-driving vehicles. It will be going to helping self-driving cars and then it will be identifying the stop signs, pedestrians as well as lanes in real time, okay? So this is how the deep learning works, okay? So I will explain by code, okay, how to import some torch and then how to import some libraries in this deep learning, okay? So I will switch over to my code editor so that you guys are easily understand these concepts, okay? Okay, I'm using Google Colab here, so that only it will be easy to understand, okay? Okay, see, I already write this code. See, import torch. This one is the core library for the deep learning, okay? And then I'm using a torch.nn as nn and then torch optim. These are the libraries in the deep learning. You will just import this one, okay? Just you have to import in your Python code editor, okay? I'm using Python code editor and then you have to print the torch version, that means Python torch version, torch.version, okay? It will be display the PyTorch version : and then it will be display here the version, okay? and then device, you will going to see search the device in that, okay, torch dot device. So which device we will be going to using that torch, where we will be going to import the particular device will be displaying it. When you run this code means it will be display that PyTorch version is 2.11 something, okay, and then this one is the using device. I'm using CPU here, so that will be display like CPU, okay. This is how you have to importing the libraries in the deep learning, okay. Next we are going to see that another one concept, that one is I hope you understand this one, okay. Next we are going to see this is how you have to importing the packages, okay. Next one we will be going to see that machine learning versus the deep learning, okay. To understand deep learning, we need to know where it fits in the grand scheme of technology. That means think of it like a set of nested circles. See the image like a nested circle, okay. The outermost layer, I am saying that nested circle where will be three circles. The outermost layer will be the artificial intelligence, okay, which is basically like it enable the computer to act like a human behavior, okay. So instead that next one is a machine learning, so which is a subset of AI. That means it will be providing inside the A, okay. So which is used to statistic methods. It will be using a statistic method. That means like it will going to enable the machine into improve the experience, okay. With the experience only it will be identifying the patterns, okay. And then another one is the deep learning, we already said, which uses a multi-layered neural networks. It will be identifying the pattern and it will going to respond our needs, okay. So look at the difference, guys. First one, I am saying that feature extraction. What this means, in machine learning and all, humans must do the manual feature selection. That means like humans only going to interact with the computer and say that what kind of pattern is this, and we have to explain that all the things, okay. But in deep learning, the network itself learned automatically, okay. And then data set size. So in machine learning and all, it will be work with this smaller data sets, okay. But in the deep learning and all, it will be more hungry for data. That means it will be using a massive amount of data, okay, in the deep learning. And then model complexity, another one difference, okay. Model complexity means just machine learning and all, it completely relies on mathematical model, that like linear regression and then decision trees, that kind of things, okay. But deep learning uses a layered neural networks, okay. And then data type, machine learning uses a structural tabular data, okay. Structural tabular data is nothing but it's like a spreadsheet, okay. We will be using a Google spreadsheet and all, likewise only. And then deep learning is like unstructured data. That means raw data, raw video streams, audio recordings and text blocks, okay. So I will explain the machine learning and deep learning difference using a codes, okay, so that only you guys are easy to understand that concepts, okay. I'm switch over to the my code editor, so that only you will be easy to understand, okay. Okay, wait guys, I hope you will see my screen, right? Yes. Okay, I'm using my code editor. So see here what happened means this is a difference between machine learning as well as deep learning definition, okay. See class name, I'm using a class name traditional machine learning model, okay. And another one class, that is a deep learning model, okay. I'm using the two classes, okay. Here def means like it's a definition in it, and then I'm giving some two parameters. That one is a self comma input dim. This one is a dimensions, okay. So here also I'm using the two parameters also, okay. The super of is a keyword in the deep learning. Okay, super of, okay, I'm using super of keyword here, and then I'm using a self dot linear. NN, we will be already importing the torch. That one contains the NN, and then linear, and then you have to give the input dimension 1. Here the input dimension will be 128. Okay, and then you have to give a linear, and then you have to give two parameters for that, 128 and 64, and then you have some give some parameters value. Okay, relu off, and then linear off. These are the importing packages. Okay, we will be already importing a torch package. No, it will contain these kind of things only. Okay, and then you have to forward to the self x is just a value. Okay, and then you have to return the torch sigmoid. Okay, and then inside that you have providing the self network. Okay, see how it runs. Okay, it will not providing any kind of thing. It will just I'm giving a simple definition for that. Okay, it will be using something called super keyword here, and then this one is also given by the super keyword. Also it will be going to forward the, we will not printing anything here, just we will be returning the network here. Okay, so this is how the traditional as well as the machine learning model works. Okay, I hope you understand this one. Okay, next we are going to see that another one concept. That one is so these are the major difference between the machine learning, artificial intelligence, and then deep learning. Okay, next guys, see this is also a glance of difference between the machine learning and deep learning. You will note it in your notebook or something. Okay, so that only it will be not forgotten easily. Okay, next we are going to see that another one concept. That one is a neural network. Okay, so neural network is nothing but it's like a system of interconnection nodes. That one is called the neurons. Okay, so with that one is used to processing the information. Okay, it also organized into three types of layers. Okay, one is a C, the input layer, and then output layer, input layer, hidden layer, and then output layer. Okay, so input layer means like this one is a gateway. That means the first way. Okay, it will be what I will explain the working procedure of neural network. Okay, so listen carefully this session. Okay, so the neural network has consists of three layers. Okay, one is the input layer, and then another was a hidden layer, and then is the output layer. Okay, so in the input layer is nothing but it's like a gateway, the first way. Okay, so it will just receive the raw data from the outside world. Okay, and then it passes it forward, and then it will be going to pass that one. Okay, so the hidden layer, this one is called the engine room. Okay, there the computations and then where the magic will happen here. Okay, it will going to detect the pattern as well as it will be perform the calculations, and it will be extracting the futures. Okay, and then the more hidden layer we stack, the deeper the network becomes. Okay, so it will be going to perform some calculation inside that. Okay, and then the output layer, this one is called the final layer. It will be going to convert all the processed signal into a concrete prediction or else like a decision. Okay, like it will be going to decide whether an image is a cat or else the image is a dog. Okay, every single node in these layers takes the input and multiples them by weights, and then adds a bias, runs it through an activation function. Okay, the activation function is also, it contains some formulas to do that. Okay, and then it sends to the result layer. Input layer, it will be getting the raw data. Hidden layer, that process the data. Output layer, it give the specific output to that particular image or else something else. Okay, so this one is called the layers. Okay, so the input layer only the network's gateway, it will be coming from the data will be come through the input layer. Okay, so I'm showing some code for this one so that it will be not forgotten. Okay, I will switch over to my code editor. Okay, so that only you guys are easily understand that concept. Okay, See, three-layer neural networks. Okay, first one is a simple. I'm using a class simple neural networks. Okay, see here. This one is the output. Okay, so def init, inside that I'm using a self input size, hidden size, output size. Okay, the size of the particular image, and then I'm using a hidden input layer to hidden layer. It will be moved into the hidden layer. Okay, first the input layer receives the raw data and then given to the hidden layer. Hidden layer analyzes the input size and hidden size. Okay, and then activation function means this one is performing an operations. Okay, and then it will be sending to the output layer. Okay, output layer just revealing the hidden size and output size. Okay, and then it will be going to store it in a particular variable. That one is a x, and then you have to return the size of the x. Okay, and then this one is a model. Okay, model is nothing but we will be calling the class name, and then we will be providing the size of the particular layers. Okay, input size means 10, hidden size is 5, and then this one is a 2. Okay, so and then we will print the model. So see what is the output inside the class name. That means a simple neural network. Okay, the hidden, ReLU, and then output. These are the three layers. The first one is a linear. It will be showing the 10, 5, and then bias will be a 2. Okay, and then in futures will 5, and then out futures will be 2. It will be modifying that values here. Okay, see the 10 example, 10 future, hidden size 5, output size 2 means it will be showing that hidden size 5, output value will be 2. First it will be 10, 5, and then 5, 2. Okay, this one is the input future, this one is the hidden size, this one is the hidden size, and then output size will be 2. The bias value will be always in a true conditions. Okay, so this is how the layers will be working. Okay, the three layers. And then now we are going to see about the another one concept. That one is the input layer. First input layer. Okay, so this one is an important concept, so I separately giving all the topics here. Okay, so the input layer is nothing but it's like a gateway. Okay, okay, so guys, let's zoom in on the first layer. That one is the input layer. As I mentioned above, it is the ears and the eyes of the network. But computers don't understand the image or words the way we do, right? And they only understand the numbers. That one is zeros and ones. So the input layer job is to take the raw data and represent that one as the zeros and ones. Okay, it will be going to convert that particular input into zeros and ones. Okay, so that's the work of the input layer. Okay, it will taking the image pixels, audio signals, text data, and the numerical data, any data, it will be automatically convert the data into the numerical value 0 to 255. Likewise, it will be changing the values. Okay, so that's the work for the input layer. Okay, next one is like a output layer, the hidden layer. Okay, next one is like a hidden layer. So the hidden layer is nothing but it's like where the magic happens. Okay, now we enter the hidden layer means this is the real learning happens. Okay, it is called hidden because the user doesn't see these middle steps, only the inputs are going in and the outputs are coming out. As data moves through the hidden layers, the network, it will be going to increase the abstract concept. In the first hidden layer, it might detect simple edges as well as lines. Okay, in the next layer only it will going to combine all those lines to detect these shapes, like this one is the circle shape and then square shape. Likewise, it will be going to identifying the shape. In the deeper layers and all, it combines those shapes to recognize the complex future. That means it will be combining all the ways, like it will be combining the eyes and then ears and then nose and then mouth, and then it will be going to combine all these, and it will be going to find that particular image. Okay, so this is how the hidden layer will be works. Okay, it contains some activation functions also that will allow the network to learn the complex data. Okay, so and then we are going to see another one, that one final layer, that one is the output layer. So this layer is nothing but it will be taking all the future extracted by the hidden layers and then translate them into a final decision. Okay, so guys, depending on the issue, that means depending on the problem only we are solving the data. Okay, that data will be comes from the output layer. Okay, so for example, binary classification means if you want to decide, binary means two, like yes, so if you want to decide between two choices means like spam or not a spam, or is dog or a cat, like means you in a dilemma mode, means the output layer has a single node. Okay, so we apply a sigmoid activation function, that means the value of sigmoid activation function, it will be a 0 or 1. Okay, but it representing a probability that 0.5. Okay, we predict class A or otherwise class B, right? So multi-class classification, one is a binary classification, another one is a multi-class classification. Now this is nothing but if you have multiple classes, that means cat, dog, bird, flower, etc. The output layer has only one node per class, so that only it uses softmax activation function to turn the raw scores, that means raw data scores into the probability distribution, that means 1 or 0. Okay, so this is the highest probability is our final prediction. Okay, it will be getting zeros or ones from the computer and it will be displays the output to us. Okay, next we will be going to see how the deep learning works in the real time. Okay, so this is most critical slide of this presentation. Okay, this is nothing but how learning actually happens. Okay, so guys, this is nothing but the deep learning working strategy, right? So it will, first one is the input data, that means forwarding the pass. We will be feeding the input data to the network. It flows through the layers and then it will be making some calculations and then the output layer generates a prediction. Okay, so here I'm saying one thing is like a loss function. Okay, loss function, why? Because means when we comparing the network prediction means with actual correct answer. Okay, the difference between them is the loss data. Okay, our goal is to make this loss data zero as possible. Okay, so we will not providing a wrong answers. Okay, we will providing wrong answer means the loss data will be increases. Okay, and then next one is the back propagation. Back propagation is also a concept in the deep learning. This will show how much each individual weight in the network, that is contribute to the error. That means we send the error signal. Okay, so error signal to the network by using a calculus concept, that one is called a chain rule. Okay, so we will be analyzing the amount or detecting the weight of error. Okay, for that only we are using this concept. Okay, so guys, think of it like a learning to play a musical instrument. Okay, so like you play a note means you hear that it sounds slightly off and then you will figure out with the finger was placed wrong. That one is the back propagation and then you will be going to adjust your finger for the next attempt. Okay, and then you have to repeat this process thousands of time until you will playing the song perfectly. Likewise only it will also acting, it will be providing the input data, it will making some calculation and then it will be adjusting some weights that to prevent the loss of the data, and then it will providing the output prediction. So output prediction and then input data, we will be comparing these two means there is no loss of data. Okay, that the loss of data is occurs means there is so much of error in this deep learning. Okay, so likewise only we will be understand this concept. Okay, next one we are going to see that important concept, that one is the real world application. Deep learning is transforming industries around the world. Like deep learning is no longer just a research topic. It powers many of the systems we interact with daily, like face recognition. I'm already saying this example, right? Face recognition, self-driving cars, medical imaging. Medical imaging means it's like a MRI scans, X-ray scans, radiologists use deep learning models to identify these scans. Okay, X-rays, MRIs. Often it will be used to spot the details that might be missed by the human eye also. Okay, and then voice assistant means we are using a ChatGPT, Siri, Google Assistants, using these transformer architecture to understand the content structure and generate human-like conversations. Right. So these are the major examples that are used in the deep learning. Next we are going to the end of this session. So guys, thank you so much for watching this session. So I hope you will understand this concept. Keep learning and then keep learning with Life Changes Academy. So thank you guys, we will see in the next video. Okay, so until then, thank you. I hope you understand this concepts. Okay, you have to make practice of that. Okay, you have to make a code of that. Okay, so that only this concept will be more familiar for you. Okay, so guys, thank you. See you in the next video. Bye.